Hello and welcome to Green Philosophers channel. My name is Aiden. This is my friend Aristotle, and today we're gonna learn about atomic structures and isotopes. But before we start, please like and subscribe to not miss our future videos. And let's begin. Right now we are at some chemistry lab here, and let's learn about atomic structures. Atoms are made of electrons, neutrons, and protons. An element has the same number of protons and neutrons, but the number of neutrons can vary. These different forms with different amount of neutrons are called isotopes. Use the element constructor to make isotopes of hydrogen and carbon. What do you notice about number of protons in an element and its atomic number? Let's do it. We have here the element constructor, and we need to make hydrogen. Hydrogen has three forms called isotopes. The most common form has one proton, one neutron, and one electron. And this is the hydrogen. Also another from isotopes of hydrogen called deuterium. It has one proton, one neutron, and neutron, and one electron. Also, there is another form of hydrogen, which is called deuterium. It also contains one proton, one electron, and one neutron. And this way, we can get the deuterium hydrogen. Also, if we want to get other elements, we can get, for example, tritium, which is also isotope of hydrogen, and it has one proton, two neutrons, and one electron. Isotope has the same chemical properties as each other, but different physical properties. For example, they have different masses. Some isotopes may be stable, while other may be radioactive. And to get the oxygen, we need to put 6 protons, 6 electrons, and 6 neutrons. And this way we can get the carbon. And oxygen, I believe it was more. This is sodium. This is neon. This is fluorine. This is oxygen. If we have 8 protons, 8 electrons, and 8 neutrons. This is nitrogen. Carbon, we just learned. This way we can get boron. Lithium. Helium. And let's continue our journey to learn more about atoms and protons. Let's go. This is our experiment lab. We can use it later for future experiments as well. Hello. What is the world made of? We don't just make new chemicals in our labs. We can also look at natural materials and find out what they are made of. For this lesson, you will need to hunt down some natural materials. Once you will have done that, bring them into the lab and put them in the material reducers. All natural and synthetic materials are composed of chemicals, be they elements, molecules, or compounds. Many materials have similar elemental compositions but different properties. For example, most stone-like materials are composed of silicon and oxygen, whilst living things are largely carbon, oxygen, nitrogen, and hydrogen. The material reducer is similar to real-world instruments used to measure the element composition of materials. Let's now use the material reducers to try and see how it works. We just need to take some materials. This is chemicals. This is liquids, poisons, explosives. Do I have any materials here? Let's check here as well. No, it is all the same. Okay, let's then have a look. Let's have a look at this one. We need to take some material. Stack the diamond block, emerald block, gold of 1 block of diamonds consists of 36 carbon. Oh, 1 block of diamond consists of 100 carbon elements. Interesting. And what is the block of emerald consist of? This consists of oxygen, silicon, beryllium, and aluminium. And block of gold give us gold. Yes, block of gold give us only gold. This is correct. Let's continue. Properties of matter. Now the labs are safe. It is time to make some chemicals. Start by collecting elements from the chemical stores. See what happens when you put 2 hydrogen and 1 oxygen atom in the compound creator. Then add another oxygen. There are lots of more compounds to be made. Make some soap and potassium iodide. Then put all 3 chemicals together in your crafting table. Trust me, you will like what you will see. Okay, let's write down what we need to do. We need to take, let's go to craft table one more time. So we need to go to compounds here. I believe it is this one. No, it is not this one. This compound creator. We need to put 2 hydrogen, 2 hydrogen and 1 oxygen. We will get water. Yes, we'll get water. Okay, let's continue our journey here. Learning more about molecules and atoms. What is this about? Some chemical formula. Formulas of salt, water, epichlorite, potassium iodide, sodium, sugar, soap. Oh, great. Have you tried making glow stick here in the lab? Yeah, we have made the glow stick before. Yeah, thank you. But we'll make also the ones a bit later. Hello. It's been great seeing you here. Thank you. We just have one more thing for you to do. We're sure you have noticed that there are all sorts of ways that this world different from yours, and lots of the chemistry is different as well. For example, did you know that in your world TNT can explode underwater, but it doesn't in Minecraft? But here you can add sodium to TNT to make it explode underwater. Why do you think the game designers make it that way? Before you go, do some more experiments and then research how they compare to your world. Maybe you can start by making some colored torches and then doing flame test in the real lab. Okay. New science starts with an observation. I noticed, which leads to a question. I wonder. Then a hypothesis. I think that. Then experiment to check the hypothesis. I will test my idea. The experiment may produce a new observation, and so on. At some point, the scientist may form a conclusion. I discovered that they wish to report to other people. Then anyone else can join. Now design your own experiments. Okay, we will do experiments, but in the next episode. This episode we are still learning more about moleculars and atoms. So let's have a look what else we have here. This is our lab here. Hello. Chemistry all around you. You don't need a lab to do chemistry. Chemical reactions happen all around you all the time. Can you find some examples of chemical reactions in Minecraft? Explore the biomes and bring back materials and objects you could use to demonstrate some chemistry. Then use this build space to show the chemistry in action. Oh, yeah, we'll do this as well. X-axis. Scientists use lots of ways to represent chemicals. They use common names, chemicals names. They could write formulas, or they build models of molecules. For example, water could be called dihydrogen monoxide, or H2O. Look around the landscape. Can you find the model of water and some other chemicals models? Then come back to building space to create your own modular model. Okay, well, yeah, let's check. This is the molecule of water, I believe so. If you know what is this molecular is about, please write down the comments below, and the correct answer we will reveal in the comments as well later. Thank you for today. In the next episode, we will do more experiments and we'll make new materials, use some formulas, and dive more into chemistry. And thank you for today, and see you tomorrow.